Good morning, dear students. A warm welcome to all of you for today's digital session for the subject Science and Technology Section A. In our previous session, we have started with a new chapter from Physics, chapter number 11, Reflection of Light. In this chapter, we have studied about mirror and the two types of mirrors in our previous online session. Let us just have a glance at this topic and then we will start with a new topic for today, that is Introduction to Concave and Convex Mirrors and the types of images formed by both of them. So let us see what is a mirror and what are its two types. You all know mirror is nothing but a reflecting surface, or in scientific language if you have to speak, a surface which reflects light and creates clear images is called a mirror. It is of two types, plane mirror and spherical mirror. I don't have to tell you more about plane mirror. The mirror which you look in the moment you get up in the morning, before coming to school, anytime the mirror which you look inside for your image, that is a plane mirror which is made by coating the back surface of a flat and smooth glass piece with a thin reflecting film of aluminium or silver. And I don't have to tell you that plane mirrors, they are used in various activities in our day-to-day life. Now let us see about or get introduced to more topics, to images which are formed by a mirror. Now when you look or when you stand in front of the mirror which you have in your house, that is the plane mirror, we see a clear image of ourselves. To understand how an image is formed in a mirror, first we are going to consider an image which is formed by a point source. Image which is formed by a point source. Now light rays, you have studied about light. Light rays travel in all the directions from such a source, and several of these rays, they fall on the mirror. About the rays we are going to see ahead. Several of these rays, when they fall on the mirror, they appear, you can say they get reflected and then they reach our eyes. In the beginning I have told you how the light, the things can be visualized by us. Due to reflection, they appear to be coming from a point behind the mirror, and that point is called the image of the point source. Look at the first figure over here. Here, rays falling on a mirror normal to its surface. Here you can see light rays falling perpendicularly on the mirror and they are reflected back in the perpendicular direction. Incident ray, reflected ray, means they are falling perpendicularly on the mirror and reflected back in the perpendicular position. Let us look at the next diagram over here. Here this figure, it shows a point source O in front of a plane mirror. You can see over here point source O in front of the plane mirror, which is M1 and M2. This is your plane mirror. Incident rays OR1 and OR2, they get reflected according to the laws of reflection. You have studied about the laws of reflection. This is your OR1 and this is the other ray OR2. These are the incident rays. They are incident on the plane mirror from a point source which is O. Now according to the laws of reflection, they get reflected along the paths R1, S1 and R2, S2. These are the two paths of reflection. Now when this reflected rays, they are extended behind the mirror. These are the reflected rays. If you extend them behind the mirror, you can see this is point O1. So they meet at this point, which is point O1, and when seen from E, when they are seen from E, the rays appear to be coming from O1. Other rays starting from this point source O, they get reflected and appear to be coming from O1, and thus you can say that O1, this point O1 is the image of point O or whatever object it is. I hope you have understood. Again in simple words I will tell you. Here a point source O is in front of a plane mirror M1, M2. Two incident rays, that is OR1 and OR2, they get reflected along the paths R1, S1 and R2, S2. Now when these reflected rays are extended behind the mirror, they appear to meet at this point. They meet at this point O1, and when they are seen from this point E, they appear to be coming from this point, and this point O1 is called the image of point O. Now the reflected rays do not actually meet. Do they actually meet over here? No, they appear. So the reflected rays do not actually meet, and hence such an image is called a virtual image. The perpendicular distance of the image from the mirror is equal to the perpendicular distance of the source, whatever is the source, from the mirror. Next, third, if we use an extended source instead of a point source. Now here it was a point source O. So in place of this point source, if you are using an extended source, then an image is formed of every point of the source, thereby forming an extended image. Now you can see here in this figure an extended source PQ. This is the extended source PQ. It is kept in front of the mirror. This is the plane mirror M1, M2. The image of P and Q are formed at P1 and Q1 respectively. Similarly, images of all the points between P and point Q, they are formed in between P1 and Q1, resulting in the image P1, Q1 of the entire extended source. And thus you can derive that the image which is formed by a plane mirror is of the same size as the source. This is an important thing which you have learnt. The image formed by a plane mirror is of the same size as the source. Now you have studied about proofs in geometry. Let us see one of the proofs here in physics. The statement says, in order to see the full image of a person standing in front of a mirror, the minimum height of the mirror must be half the height of the person. See, you stand ahead of the mirror, in front of the mirror. So if you want to see your full image, then the minimum height of the mirror in which you are looking, it must be half the minimum height of the mirror. It must be half the height of the person. We have to prove this statement. For this statement, you can see here a figure on the slide. Here in this given figure, the point at the top of the head, the eyes, and a point at the feet of a person, they are indicated by H, E and F respectively. Head, H, eyes, E and F is the foot or the feet, you can say. They are indicated. This is the point at the top of the head, the point at the eyes and the point at the feet. They are been indicated by these 3 points H, E and F. R and point S, they are the midpoints of HE and EF respectively. You have studied about geometry. What is the midpoint? A point separating this into 2 equal parts is called the midpoint. So R and S are the midpoints of HE. You can see here R is the midpoint of HE and S is the midpoint of EF. The mirror PQ is at a height of NQ. You can see this mirror PQ, you can see clearly. It is at a height of NQ from the ground. Assume this is the ground and it is perpendicular to it. PQ is the minimum height of the mirror. PQ is the minimum height of the mirror in order to obtain the full image of the person, and for this RP and SQ. RP and SQ should be perpendicular to the mirror. Find out why. Why you have to find out. So minimum height of the mirror PQ is equal to RS, which is equal to RE plus ES. RS is what? RE plus ES. Now what is RE plus ES? So RE is nothing but HE divided by 2, because R is the midpoint. So RE is HE divided by 2. At the same time, what is ES? EF divided by 2. Here you have to apply geometry, and which is equal to HF divided by 2, because HE plus EF comes out to HF, that is HF divided by 2, and which is equal to nothing but half of the person's height. See how they have applied. What is this? RS, PQ is equal to RS. RS they have divided into RE plus ES. Now R and S are the midpoints. So what is RE? In place of RE they have taken HE divided by 2. In place of ES they have taken EF divided by 2. So HE plus EF, denominators are same, comes out to HF. HF divided by 2 means height of the entire person divided by 2 means half of the person's height. Here the statement is proved that in order to see the full image of a person standing in front of the mirror, then the minimum height of the mirror, it must be half the height of the person. Now, after studying about plane mirror, we are going to study about the next type of mirrors, spherical mirrors and its types. You have seen about the different mirrors when you have visited the Nehru Science Center. Also, you might have seen the mirrors which are displayed in the laughing chamber when you have visited any fair or somewhere. Now here if you see in the mirror, your face, it appears distorted. It does not appear familiar. Why? Because these mirrors are different from the mirrors which we have at home. Which topic we are studying about? We are studying about spherical mirrors. So these spherical mirrors are different from the mirrors which you have at home. They are curved. And the images which are formed by the curved mirrors, they are different from those which are formed by the plane mirrors, and because of this you do not see the familiar images. You can see the images are different from the original person. Now what is the spherical mirror and how it is formed? Now if you cut a rubber ball into two parts, as you can see here in this given figure, we can see that each of these two parts has two types of surfaces. And generally, what are spherical mirrors? They are just the parts of the hollow glass sphere. Like you can see this part B over here. The inner or the outer surface of this, if you just cut a rubber ball, then whatever part you will get, it will have one inner surface, it will have one outer surface. So the inner or the outer surface of this part is coated with a shiny substance, and thus a spherical mirror is produced. And here reflection of light, it takes place either from its outer surface or inner surface, and based on this, spherical mirrors are of two types. One is concave mirror and the other is convex mirror. Concave, inner surface of the spherical mirror is the reflecting surface. Cave, remember this word. How is a cave? You know the shape of a cave. So when it is like a cave, so concave mirror, so inner surface, if the inner surface of the spherical mirror is reflecting, then it is called a concave mirror. On the other hand, convex, if the outer surface of the spherical mirror is the reflecting surface, then it is called a convex mirror. So here we have studied about the two types. We have got ourselves introduced with the two types of spherical mirror, concave and convex. It can be asked in the exams either as a true or false, a fill up, or a sentence can be asked. If the outer surface of the spherical mirror is reflecting, then it is called a concave mirror. False. So you should know it thoroughly. Now we are going to study the different terms related to this spherical mirrors. You can see here the spherical mirror being displayed in front of you. The first term which we are going to study is the pole of the mirror. The center of the mirror surface is called its pole. The center of the mirror surface is called its pole, and in this figure P, you can see P is the pole of the mirror. So this is your first term. Our second term is center of curvature. You can see here in the center it is C. The center of the sphere of which the mirror is a part is called the center of curvature of the mirror, and it is denoted here as capital C. So pole of the mirror, the center of the mirror surface, it's called its pole, and the center of the sphere of which the mirror is a part is called the center of curvature, represented by capital C. All these terms should be learnt by heart by you. They can be asked as true or false or direct definitions. Third is the radius of curvature. In geometry, you have studied about the radius of a circle. In order to draw any circle, you should have a radius. So here, the radius of the sphere of which the mirror is a part is called the radius of curvature. In short, the radius of this circle. In geometry, you have studied about radius. So that is nothing but the radius of this spherical mirror. And you can see over here CA or CP, which is the radius of your circle, normal circle, that is the radius of curvature. Our fourth term is very easy. This line you can see passing through the center of curvature and the pole of the mirror. It is called the principal axis, or in short your diameter of the circle. Here you can see the straight line passing through the center of curvature and the pole of the mirror is called its principal axis. And next is slightly difficult, principal focus. It is different for a concave and a convex mirror. The incident rays which are parallel to this principal axis of a concave mirror, in case of a concave mirror, after reflection they meet at a particular point in front of the mirror, and that point on the principal axis, it is called as focus. You can see this capital F. This point F is called the principal focus, whereas in the case of convex mirror, this incident rays which are parallel to the principal axis, after reflection they appear to come from a particular point behind the mirror lying along the principal axis. This point is called the principal focus of the convex mirror. And last, very simple, is focal length. The distance between the pole and the principal focus of the mirror. The distance between the pole and the principal focus of the mirror, it is called the focal length, and this distance is half of the radius of curvature of the mirror. So these are the different terms which we have studied related to spherical mirrors. Let's have a glance at it quickly. One is the pole. You can see the center of the mirror surface, it is known as the pole. The center of the sphere of which the mirror is a part is called the center of curvature. CP or CA, that is the radius of the sphere of which the mirror is a part, is called the radius of curvature. Then you have your principal axis, that is the straight line passing through the pole and center of curvature. Then you have principal focus, different for concave and convex mirror. And last, focal length, the distance between the pole and the principal focus of the mirror is called its focal length, and it is half the measure of radius of surface curvature of the mirror. Now, what basic criteria has to be followed while drawing the reflected rays, that we are going to study here, because we are going to study the images which are produced by the spherical mirrors by drawing the ray diagrams. Now you can see here this figure. Now in this given figure, you can see this MN is a spherical mirror, and ray AQ is incident on it. Incident means it is falling on this mirror, so it is called as the incident ray. So Mn is a spherical mirror and ray AQ. How you can say incident? You can see arrow here, means falling on the mirror, and CQ is a radius. You can see this. CQ is a radius and therefore is perpendicular to the mirror at point Q. Radius and perpendicular to the mirror at point Q, and thus you can say that angle AQC is the angle of incidence. According to the laws of reflection, which you have studied in the earlier standards, angle of incidence and angle of reflection must be of the same measure. You can see here ray QB is the reflected ray, and thus while drawing the reflected ray QB, here you should take care that angle CQB, this angle, must be equal to angle AQC. It should follow the laws of reflection, that is angle of incidence should be equal to angle of reflection. Ahead now we are going to study the rules which we are going to follow for drawing the ray diagrams for images which are formed by spherical mirrors. Now what is a ray diagram? A ray diagram is nothing but the depiction of the path which is taken by light rays. Now there are different rules which has to be followed while drawing the ray diagrams. 3 rules are there along with the 3 diagrams. It can be asked in the exam. So the first rule is, if an incident ray is parallel to the principal axis, this is the incident ray. If an incident ray, this is your principal axis, you can see line passing through the pole and center of curvature. So this is your principal axis. So if an incident ray is parallel to the principal axis, then the reflected ray, it passes through the principal focus, that is capital F. This is your first rule which you have to follow while drawing the ray diagrams for images which are formed by spherical mirrors. So if the incident ray is parallel to principal axis, then the reflected ray passes through the principal focus. The second rule is contrast to the first rule. If an incident ray, it passes through the principal focus, then the reflected ray is parallel to the principal axis. Look at both the rules. First rule says, if the incident ray is first rule, if an incident ray, it is parallel to the principal axis, then the reflected ray passes through the focus. Second rule, contrast, if an incident ray passes through the principal focus, then the reflected ray is parallel to the principal axis. And the third rule, if an incident ray passes through the center of curvature, you know the center of curvature of the mirror, the reflected ray, it follows the same path back. So these are the 3 rules. It can be asked anyway in the exam. Directly I can give you the diagram and I will ask you to identify the rule related to the ray diagram and state the rule. Or 3 marks I can ask, state the 3 rules for drawing the ray diagrams for image formation by spherical mirror. If the rules are asked in the exam, then each and every rule should be supported with the diagram, otherwise half mark will be cut. Our next topic now is, you have going to study the images which are formed by both the types of mirrors, that is images formed by a concave mirror and images formed by a convex mirror. Out of that, today we are going to study about the images formed by a concave mirror. Here the position of the object, when the object is located at different positions, according to the position of the object, what is the position of the image, what is its nature and what is the size. So in depth we are going to study about 2 positions when the object is placed between the focus and the center of curvature of concave mirror. So here you can see this is an object AB. The first we are going to study about the image when the object is placed between the focus and center of curvature. So you can see here this is the object AB which is placed between the center of curvature and principal focus F of a concave mirror MN, This is your concave mirror. Here the incident ray AQ. This is the incident ray. It is passing. You can see here on the mirror. You can see arrow in the downward direction towards the mirror. So AQ is the incident ray starting from point A and going through the focus F. It is passing through focus F. It becomes parallel to the principal axis. You can see over here. It becomes parallel to the principal axis after reflection and returns along path QR. Sorry, not this. This is the incident ray and this is your reflected ray. It is passing through QR. Incident means arrow towards the mirror and reflected going out away from the mirror. It is passing along QR. Next is the incident ray AS. You can see this is the another incident ray AS with the arrow towards the mirror, which is parallel to the principal axis. It is after reflection passes through the focus and then passes, or you can say it returns along the path ST. Here you can see both the rules are followed. If the incident ray is passing through the focus, we have studied the rules just now, then the reflected ray is parallel to the principal axis, and if the incident ray is parallel to the principal axis, then the reflected ray is passing through the focus. Now this ray, it is cutting the reflected ray QR. It is cutting your reflected ray QR at point A1, A/A1, whatever you are saying, and thus the image of A is formed at A1. The point B, you can see over here, it is situated on the principal axis, and so its image will also be formed on the axis and it will be directly about A1 at this point, that is B1, and thus the image of B, point B is at B1. The image of the points between A1 and B1 will be formed between points A1 and B1, and hence the image of the object AB is A1, B1, or A/B/, whatever you want to say. The image of object AB is A1, B1. So from this, what we can see that when the object is placed between the focus and the center of curvature of the mirror, where is the image formed? The image is formed beyond the center of curvature, and this image is larger than the object and inverted. See, A is over here, A has come down, so the image is inverted. You can see its length, it is larger than the object. As the reflected rays actually cross each other, the image is a real image, and always remember, a real image can be obtained. It can be projected on a screen. Next position we will study when an object is placed between the pole and the focus of the mirror, that is P and F. Now you can see here an object AB. This is an object AB. It is placed between the principal focus and pole of the concave mirror. Here the incident ray AQ is parallel to the principal axis. You can see the small blue colored ray AQ incident. You can see arrow towards the mirror. It is parallel to your principal axis, and the incident ray AS is in the direction joining A with the center of curvature. The other ray, incident ray AS, you can see over here, it is joining A with the center of curvature. Now this figure, it shows how these rays get reflected and they form the image A1, B1 of the object. Now where is this image? This image is behind the mirror. It is erect, it is not inverted, and again larger in size than the object. And as the reflected rays do not actually meet but they appear to come together behind the mirror, such a type of image is called as a virtual image. Now in the table ahead we are going to study about the position and the type of image which is produced by a concave mirror when the object is placed at different distances. First position is between the pole and the focus, which we have seen just now. See here, when the object is between the pole and the focus, where is the image? Behind the mirror. You can see it is erect and even it is magnified, larger in size, virtual. So between the pole and the focus, so position of the image is behind the mirror, erect, virtual, and large in size means magnified. When the object is at the focus, then the position of image is at infinity. Inverted is the nature of the image and real, and size of the image is very large. When it is between the focus and center of curvature, this we have seen the very first case. Just we will go to that slide. See here, when it is between the focus and center of curvature, you can see the nature of the image. The image is larger than the object. Nature is what? It is real and inverted. So let us see whether it is correct. Yes, beyond the center of curvature, inverted, real and large. So magnified. When the object is at center of curvature, the position of the image is also at the center of curvature, inverted, real and same size of the object. When the object is beyond the center of curvature, then the position of the image is between the center of curvature and focus. Nature of the image is real and inverted, size of the image is diminished. And when the position of the object is at a very large, that is infinite distance, then the position of image is at focus, inverted and real, and size of the image is point image. So this table you have to just go through. Nothing I have asked from this part in the exam, but this part should be followed by you, because not about the mirrors but about the lenses. Same ray diagrams, then the terms related to lenses, everything you have similar in the 10th standard. In 9th standard you have studied about mirrors. In 10th standard you are going to study about the lenses. A full chapter you have on that. So the ray diagrams and all, if you understand in the case of mirrors, then very easily you can understand in the case of lenses also. So with this we wind up our today's session. In our tomorrow's session we are going to complete with the explanation of this chapter. We will see how the image is formed in the case of concave mirror, then why the concave mirror is called as a converging mirror or a focusing mirror, and why convex mirror is called as a dispersing mirror, and towards the end we will study about the mirror formula. So I request all of you, before attending tomorrow's session, read the remaining part of the chapter from the textbook and then attend the session. Thank you, dear children.